lesson, we were talking about the three different equations for kinetic, gravitational potential, and elastic potential. And we did an example for each one. So we did an example for kinetic. We talked about the units for energy, which are going to be joules. The unit of energy is joules. Then we did an example for gravitational potential, an example of elastic potential, and then we briefly talked about what the assessment is going to look like for this unit. We talked about the three different states that are going to be in this example for the assessment. There's going to be a box at the top of a ramp. It's going to be released, and it's going to slide down the ramp. It's going to travel horizontally for a certain distance along the ground with no friction, and then it's going to fully compress the spring, and then it's going to get launched back up, and it's going to repeat that forever. So the three different states were up here at the max height. State 2 is when it is no longer traveling down the ramp and it's traveling horizontally across the ground. So that would be at state 2. And then state 3 is when the spring would have been fully compressed. So it's the instant right before it gets launched back in the opposite direction. So those are the three different states. So what we're going to cover today is how to deal with multiple states and solving for a variable. So this first example that we're going to do, there's going to be two different states. There's going to be state 1, where this ball is up a certain height from the ground, and the ball is going to fall, and state 2 is the instant right before it hits the ground. And I want to determine what the velocity is of that ball the instant right before it impacts the ground. So that's my objective. I want to figure out how fast is it going the instant right before it hits the ground. Cool. Let me get Jaylee for attendance. All right, did Sean or Trevor come in? I don't think they did. No. Okay. All right. So we want to find V2. So V2, and I like to put my variables that I'm solving for in square brackets, because if I've got M like this and I've got M like this is meters and this is mass. Okay. So my objective is I want to figure out what the velocity at state 2 is. So when we solve these kinds of problems, at state 1, I have the object a certain height from the ground. So this would be H1. And we're going to say that H1 is 300 meters high. So it's pretty up there. It's pretty high. All right. And we're going to say that the mass is equal to, let's say, 15 kilograms. And I don't remember if we went over that video. Did we discuss the video with the bowling ball and the feathers? I think we did. I could be mistaken. Does that sound familiar? Maybe not. Okay, so maybe after the live stream, I'll discuss this. That actually might tie in well. So let's see. So when it comes to the height, there's a reason why I have a 1 right here to indicate the height at state 1. So between the two different states, remember the states are And when I give you guys a problem like this, I'm going to have two different figures to represent the two different states. But I think it might make a little bit more sense because this is digital. I can actually move it. And when it's on a piece of paper or on your screen, it'll be difficult to create a GIF to do that. So, excuse me. At state 1, the ball is up here. And then at state 2, it's going to be down here. So the instant right before it hits the ground, that would be h2. So that's the height at state 2. And we can assume that that's going to be 0, or it's going to be so small that it's not going to make a difference in the problem. So we're going to assume that h2 is 0. Does that make sense? And of course, since we're dealing with something falling, we have to put in gravity. Cool. All right. So when it comes to having two different states, so I want to figure out what is the total amount of energy at state 1. And I know that since energy is conserved and like energy can't be added into the system or taken away, it just needs to be transformed. I know that the total amount of energy that I start with must equal the amount of energy that I finish with. So the three types of energy that we talk about in this course is, of course, going to be kinetic at state 1 plus ugrav at state 1 plus uelastic at state 1. I apologize if this is a little messy. And then it's going to be the same thing on the on the right side. The only difference being that it's going to be at state 2 versus state 1. So at state 2, state 2, state 2. Okay. Now, after reviewing the video from last class, I did not write down the questions that you ask yourself at each state to figure out which energy is present. I mentioned it, but I didn't actually write it down. So if I substitute in for each one of those with the equations that we discussed yesterday, these ones here, it'll get really big and really messy and really confusing. So let's go ahead and cancel out any of the energies that aren't even present. So in other words, we can cross out at least two of these for each state. So at state 1, this is going to be the instant that I release the ball. So does the ball have a velocity at state 1? Does the ball have a velocity at state 1? Anybody? Correct. So it does not have a velocity. It doesn't have enough time to start speeding up. So the instant that I release it, it's essentially at rest. So for state 1, there is no velocity. If there's no velocity, if this is 0, then that means that this whole side goes to 0, and that means that there is no kinetic. Does that make sense? So that's why the question that you ask is, does it have a velocity? And if there's no velocity, then of course there's no kinetic energy. All right, so the second question does the object have a height from the ground? So at state 1, the ball is up in the air. And is there a height from the ground? The ball is here. Of course, there is a height, h1. So yes, we do have gravitational potential energy. Let me do this real quick. So this is referring to kinetic. This is U grav. And then the third one is there a spring that's being compressed or stretched by the object? And that, of course, is dealing with U elastic. Cool. So you ask yourself these 3 questions for each state that you have. And so does it have a velocity at state 1? It does not. So there is no kinetic. So kinetic at state 1 goes away. Does it have a height from the ground? It sure does. So we get to keep U grav. So this stays. And there's no spring in this problem at all. So there's no U elastic. So U elastic goes away. Cool. So that's for state 1. So the only thing that we have present at state 1 is U grav. At state 1. Cool. Now, at state 2, the ball has traveled all the way down here. And this is going to be at the instant right before it touches the ground. So does the object have a velocity at state 2? So this is the instant right before it hits the ground. It indeed does. Okay, so we're going to keep kinetic for state 2. And we're going to assume that it's just the split second right before it touches the ground. So the distance from the ground is negligible. So we're going to say that no, there is not a distance from the ground. It's so small that it's not going to make any kind of noticeable difference. And then, of course, there's no spring in this problem. So there's no U elastic at state 2. So the only energy that is present at state 2, I don't know why it does that, is going to be kinetic. Is everybody tracking? Okay. Now, when it can never make my U's look good. They always look like all checked up. All right. So we've got gravitational potential energy at state 1, and then we had got all that energy turned into kinetic energy at state 2. So what I'm going to do now is I'm going to substitute in what these expand out to be. And I want you to take particular note of where I put subscripts and where I don't. So if I substitute in what U grav is, I have mass times the acceleration due to gravity times h1, which is the height at state 1. And then for kinetic energy, I have 1/2 times mass times the velocity at state 2 squared. Now, can anybody tell me why I put a 1 for the height and a 2 for the velocity, but I didn't put anything for mass or gravity? So the difference between mass and gravity and the height and the velocity is that the mass, exactly, yeah, just what Josh just said. The mass and the acceleration due to gravity are held constant throughout this scenario. So it's not changing. So there's no reason to dictate or to make a notation that, mass 1 is just going to be the same thing as mass 2. So why make the extra effort to notate, this is mass 1, this is mass 2, when they're the same thing. But the difference between the heights, there is a height at state 1, and that is different than the height at state 2. So it's important to make the differentiation with that. So the objective of this whole example was to figure out what the velocity was at state 2. So this algebra should be pretty easy. I mean, this is an honors course, so I'm hoping that you guys can do this. So whenever we're solving for a variable, I tend to box that variable and I keep it by itself. Now with this, because the v squared, or the v2 is squared, we're going to hold off and we're going to keep this stationary temporarily. So I want to get rid of the 1/2 and I want to get rid of the mass over here. So in order to do that, I can multiply by 2, and that would cancel out the 2's here. So if I do that on the right side, I do it over here. And then I want to divide by m. Divide this by m. And just to be consistent, let me do this. So divide that whole side by m. Cancels over here, cancels over there. So what I end up right now is 2 times acceleration due to gravity times the height at state 1, and that equals v2 squared. Okay. Now, I don't want v2 squared. I just want v2 by itself. So how do I remove a square? I know it's probably been a long time since you guys have seen this, but a square and the square root will cancel each other out. So if I take the square root of something that is already squared, it's just going to cancel out this square here. And if I do that on the right side, I must do it on the left side. So what I end up with is 2 times acceleration due to gravity times the height at state 1, all under the square root. And that's equal to v2. Now, I know some people don't like it where the variable, when it's solved for, is on the right side. So just for the sake of clarity, I'm going to swap sides. Okay, so this is the equation that we need. Now, before we plug in, we verify that we have everything that is on the right side. So do we have g? Of course we do. And do we have the initial height? Yes. So if I look back up at my givens, I gave you the mass, but you don't need the mass. So I'm going to explain that in just a minute. But when we're dealing with things that are falling, the mass doesn't matter. It could be a ping pong ball or it could be a truck. If I held them both at the same height, they would both have the same velocity when they impact the ground. Of course, if we neglect air resistance. I know a couple of you guys are like, wait, hold on, what? And I'll show you guys a video after in the live stream because I don't want to stream a YouTube video on YouTube live. You know what I mean? Okay. So what I'm going to do is I'm going to 2, and don't forget your parentheses as placeholders. And then the values for G, we have 10, and the height was what? 300 meters. All right, so we get 3,000, so it'd be 6,000, so the square root of 6,000. And what's the square root of 6,000? I get approximately 77.4596. And if I round to 1 decimal point, That's what I get. Cool. Any questions about that? Everybody cool with that? So what we went over today, so I'm going to do a brief overview of this and then I'm going to end the live stream. But then I want to show you guys a video explaining why mass doesn't matter. So the example was at state 1, I had a ball up at a certain height, h1, and then at state 2, it was at the point where it was almost about to impact the ground. And my objective was I wanted to figure out what the velocity was at state 2. So I was given the height, the height at state 1, I was given the mass, and I was given the acceleration due to gravity. Then we tried to figure out what types of energy are present at state 1 and state 2. And we used these 3 questions to help us whittle down what the whole conservation of energy equation on each side of the equation. So this was state 1, this was state 2. And by using these questions, we kind of simplified it so we didn't have to do as much work. And we ended up getting U grav for state 1 was the only energy that was present. We had kinetic energy as the only energy present at state 2. We substituted in what these equations were. So mgh1 for gravitational potential, and then 1/2 mv squared for the kinetic at state 2. I solved for v2, so the velocity at state 2, by doing basic algebra. We got the final equation for that. So hint, hint, Applewhite has just done the algebra for you. So usually when I box and star things, this is something that you could use on an assessment or something. I don't know, just saying. Then we just plugged in the values and we rounded to 1 decimal point. Cool.